In December of 2009, NASA launched the WISE spacecraft, which was located up here in this part of the rocket. WISE stands for Wide Field Infrared Survey Explorer, and basically what it does is it looks for heat in space. The telescope senses heat. That's something that optical telescopes can't do very well, especially on the surface of the Earth where the atmosphere blurs out the infrared and you can't see it. But from space, telescopes can not only see the optical photons of light that come, but they can also see the heat that comes from these stars. So its purpose was to study very cool stars, among other things. But one of the things that I want to focus on here is its ability to spot brown dwarfs. Brown dwarfs are basically failed stars. They're a little too small to ignite as full-blown stars and too big to be really planets. And there's a whole range of classifications for brown dwarfs, from the very hot to the very cold. The coldest class of brown dwarfs are the Y-class brown dwarfs. And we're going to focus on Y-class brown dwarfs here because they require very sensitive instruments to be able to detect. And the WISE spacecraft had such an instrument. This is a photo of the launch of the spacecraft in 2009. It was decommissioned in 2011 after its primary mission succeeded, and was then recommissioned in 2013 to search for near-Earth asteroids. So after the WISE spacecraft was launched, and after it had performed its survey of the sky, it actually surveyed the entire sky several times and provided a wealth of information to astronomers and scientists who are looking to find brown dwarfs. And over the course of several years of studying the data, they found quite a few brown dwarfs. The closest ones are these here. These brown dwarfs here. Those are the closest brown dwarfs that they could spot. They're further away than the closest star, Alpha Centauri. The Oort cloud here is the cloud of debris basically left over from the formation of our solar system, and it consists primarily, we think, of comets and asteroids and rocky debris and icy materials at the very edge of the sun's influence. It extends out to about 1 light year from the sun, which is about the extent of the sun's gravitational influence. So if an object passes out here around 2 light years away from the sun, it's not going to be attracted by the sun that much. It can't be captured by the sun. It would just pass on by. So these objects here, such as Alpha Centauri and Barnard's star and the brown dwarfs, they can't be captured by the sun. The sun is not going to attract these objects. They're too far away. They're outside of the sun's gravitational influence. Now, this is important to keep in mind, and I'll bring it up again momentarily here. But for right now, just keep in mind that the closest brown dwarf is about 6.5 light years away, and the coldest brown dwarf that we know of, a Y-class brown dwarf, that's probably a little below minus 20 degrees centigrade, which is about minus 4 degrees Fahrenheit. That would be in the 7.2 light year range right around here. And that's the one that we're going to focus on, the 7.2. And the reason we're going to focus on that one is because it's dimmer than these ones. It's not as hot. And so the infrared imagery that the WISE spacecraft took of this image is dimmer than these images because it's colder, and therefore it doesn't produce as much infrared light. If you do a little bit of research on this NIBIRU cataclysm thing that's supposed to happen, and you look into the history of things, you see that the originator of it was apparently this guy here. And his interpretation of ancient Mesopotamian religious texts, which contradicts conclusions reached by credited scholars on the subject. He claimed that a giant planet would pass by the Earth every 3,600 years and then wreak havoc on the Earth as a result, which means the orbital period of that object is 3,600 years. I've looked in other places, and it seems like everyone seems to have a different idea about what the orbital period of this object is. Some I've heard fantastical claims that go all the way out to like 20,000 years, that the period of the orbit of this thing is like 20,000 years. And my purpose of researching that part was just try and figure out what was the most fantastical longest period orbit that people have claimed. And it seems like right around the 20,000 year period is probably the longest period out there that I could find. But let's assume that the period of this object is 20,000 years. In other words, it comes by the solar system close enough to affect the planets every 20,000 years. What I wanted to do was then take that 20,000 year period and convert it into an orbit of a brown dwarf that would take it into the solar system deep enough that it could actually influence the Earth and cause havoc. There's a variety of different orbits that you could actually create to obtain a 20,000 year period, but one that actually takes it deep into the inner solar system from so far way out requires an orbit with high eccentricity. An eccentricity of 0 means that the orbit of this object would be circular around the solar system, which is way over here. And a highly eccentric orbit would be an orbit that takes it almost straight in and then straight back out. If we show the orbits here, we can see this is a brown dwarf is located here, and it has an orbital period of 20,000 years. We'll go over here and look. Over here, see, orbital period is 20,000 years. So an object, this particular brown dwarf, has an orbital period of 20,000 years. It takes 20,000 years for the brown dwarf to come in, influence the inner solar system, and then come all the way back out to this point here. If we change the eccentricity, you can see what happens to that orbit. See how it circularizes like this? If we make it a circle, and then we can see it's a circle if I adjust it this way, you can see that the orbit doesn't actually intersect the solar system anymore. It's orbiting the same distance from the solar system here as it is on the other side of the circle. So let's increase the eccentricity back up to 1, which is the most extreme kind of orbit you can have. Highly eccentric orbits like this are very unstable typically. But this is the maximum distance that you could get for a brown dwarf orbiting in such a manner that it would influence the solar system. Now, the reason I did that is because I wanted to find out how far away this brown dwarf is. And if we look, we can figure that out. We can look at the coordinates of it. Actually, I think it's on this page. Yeah, the position right here. Look at the x position. The x position is 1,478 astronomical units away from the sun. So remember that number, 1478. Well, how far away is that really in terms of light travel? How long would it take light traveling at its tremendous speed to travel from the sun all the way to the brown dwarf? Let's figure that out. So Google has a really convenient form that you can use to convert astronomical units to light years. Let's type in our 1478, and we can see that that converts to 0.02 light years, which is about 8 light days. So it would take about 8.5 days for light to travel from the sun to that object when it's at its maximum distance from the sun. But we don't really need to remember this number, just remember this number, 0.02. It takes 0.02 light years for light to travel from the sun to that object. Now let's look at this graph again. The closest cold brown dwarf is located at a distance of 7.2 light years. The maximum distance of this NIBIRU type object we're looking for is 0.02 light years, which is really, really close here to the sun. Now, if we can see an object this far away that is so cold, we should be able to see that same object really close to the sun tremendously easier. It should light up like fireworks in the sky. It should be very bright to the WISE spacecraft. It should have been one of the very first things that it saw. Let's pretend that we had 4 football fields and we placed them end to end together like this. The brown dwarf was located right over here, okay, in the end zone over here. Let's put a car here. and it's got headlights that are shining out here like this towards this end of the field. And then we walk to the other end of the field over here, and we're located over here on the 0-yard line of the end zone over here. We turn the car lights on and we observe how bright that is. That would be like a brown dwarf being 7.2 light years away. Now if we move that brown dwarf way over here to where it should be if it were to orbit in a period that is 20,000 years in duration around our solar system, where do you think we would put that car? The car would be put 1 yard away from where we're standing on that 0-yard line. So 1 yard away is where that brown dwarf would be located, or where this car would be shining its lights toward us. How much brighter do you think that object is going to be 1 yard in front of our face compared to 4 football fields away? This is the distance scales we're talking about here. The brown dwarf is going to shine very brightly in the sky, especially in infrared, if it's in an orbit that's 20,000 years in duration around the solar system. So although this seems like a long ways away, it's really peanuts compared to how far away we're seeing the coolest brown dwarf. That's significant. That means if we can see something that far away that is that dim, it should be really easy to see something that dim so close to us as this brown dwarf is to our solar system here. That brown dwarf should have lit up like a light bulb in the all-sky survey that the WISE spacecraft did. Because they didn't see anything that bright that close, it means that there is no such thing as a brown dwarf that is that close to us. So keep in mind, the WISE spacecraft imaged the whole entire sky. That means in every direction, up and down and left and right, in all 3 dimensions. It imaged everything. And as a result of that, the odds of there being a brown dwarf capable of influencing our solar system, such as the NIBIRU people claim, is 0. It's not possible. That whole theory has been shot and disproven. So again, you guys can relax. There's nothing to worry about. The people on YouTube who are claiming these things don't know what they're talking about.